Now in this lecture, we have combined all methods that we have implemented for queue using linked list in our previous lecture together. Now here, we have combined them together to see the big picture of time and space complexity of these methods over here. Now the first method is creating queue. Now when we are creating a queue using linked list, in this case we are just creating an instance of linked list class. So with this head and tail references points to null. So in this case it takes O1 time complexity because here we are not performing any time consuming operation. Now the space complexity is obviously O1 because in this case we are not inserting anything to memory. We are just creating an instance of class over here. So this will take O1 space complexity. Now when we are enqueuing an element to the queue in case of linked list, we are going to insert that element at the end of the linked list in this case. So we know that in case of single linked list, when we are inserting an element at the end of the single linked list, it takes O1 time complexity. So here enqueue method will take O1 time complexity. Now when we are calling enqueue method, each time we are inserting one element to our queue. So this means that it will take O1 space complexity. Now in case of the queue method, we are returning the first element from the linked list and we are removing that element from the linked list. Now we know that if we want to delete an element from the beginning of the linked list, in this case it takes O1 time complexity because here we are just changing the head reference to point to second node. That's why it takes O1 time complexity. Now the space complexity is obviously O1 because in this case we are just deleting one element from the linked list and this dequeues the element from the queue over here. Now the next method is pick method. Now in case of pick method, we are returning the value of first element from the linked list. Now in this case, the value of the first element in the linked list is the first element in the queue. So that's why we are just returning the value of the first element in the queue. So in this case, we are returning head value from the linked list. So this means that it will take O1 time complexity. So it's obvious that the space complexity is also O1 because in this case, an extra space is not required to perform this operation. Now the next method is empty method. Now in this case, we are checking based on the head of the linked list. So if head reference points to null, in this case our queue is empty. So based on that, we are returning true or false. So this means that it will take O1 time complexity. Now the space complexity is also O1 because in this case, space consuming operation is not performing over here. So this means that it will take O1 space complexity. Now when it comes to deleting entire queue in case of linked list, in this case we are just updating the head and tail references to point to null. So this will take O1 time complexity. So space complexity is also O1 because in this case we are not inserting anything to the space. We are just deleting the entire elements from the space. So this means that it will take O1 space complexity. Now with this, we have come to the end of this lecture. So till this lecture, we have explained the queue using linked list. So we have performed all these operations in case of queue using linked list. So hopefully everything is clear about these implementations as well. Now see you in the next lecture.